So another way that we can find our solutions to a quadratic equation is by using the quadratic formula. The quadratic formula is the formula negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Now, the way that we use this is we have an equation, a quadratic equation that's in standard form. Ax squared plus bx plus c equals 0. So a is the number in front of x squared, b is the number in front of x, c is the number by itself, and that's where these numbers come from that go in our formula here. So there's a couple rules we have to remember. We can't, in order to use the quadratic formula, the first one is that no term in the equation has a degree higher than 2. That means it can't have x cubed, x to the 4th, x to the 5th, anything like that. The second thing is the coefficient of the x squared term is not 0, so you can't have 0x squared. And the third thing is the right-hand side of the equation must equal 0. Now, the third one's easy to fix. If the right-hand side does not equal 0, then you need to add or subtract the number or expression on the right-hand side from both sides of the equation. So sometimes when we work this out and underneath the square root symbol we end up with a negative number. Well, we can't take the square root of a negative number, and so that is called either an imaginary number or a complex number. So before we get into the whole formula, let's talk about just a part of it. We're going to talk about the part, the b squared minus 4ac, which is the part that's here underneath the square root symbol, right there. We're going to talk about that part first. This particular part is called the discriminant. The discriminant. And the discriminant tells us, it helps us determine whether the solutions to the equation are real or imaginary numbers. And we could say imaginary or we could say complex numbers. That's the same thing. So when we plug our numbers in this formula, b squared minus 4ac, we're going to get one of three types of numbers. We're either going to get something positive, we're going to get something negative, or we're going to get 0, which that's true because that's what their numbers fall into three categories. They're either positive, negative, or 0. So if we get a positive number, then what that tells us about our solutions is that there are two real solutions. And that also tells us that when we graph it, our graph is going to look like this, where it just touches the x-axis one time. It has what we call a repeated root. And the third thing it's going to tell us is that if it's negative, that tells us there are no real solutions. So there's no real solutions or two complex solutions. That's another way we could say it. And that graph is one where when we graph it, it never actually touches the x-axis. Okay? So we're going to find the discriminant of a couple different problems. So when we start finding the discriminant, remember, we're starting with the standard form ax squared plus bx plus c equals 0. And our discriminant is the formula b squared minus 4ac. So the first thing we've got to figure out is we've got to figure out what a, b, and c are. So a is always the number in front of x squared. A is just the number. So in front of x squared in this case is a 1. B is the number in front of x. It's right here. So b in this case is 5. And c is this number on the end by itself, which in this case is 2. So then we put it in our discriminant formula. So the discriminant formula says b squared, so that would be 5 squared. And we always need to put these numbers in parentheses. Exponents go outside, the number just goes in the parentheses. Minus this 4 right here, this always confuses people. This 4 is always there no matter what. It's just part of the formula. So minus 4 times a in this case is 1, times c, and c in this case is 2. And then we put that in our calculator. 5 squared minus 4 times 1 times 2 is going to give us 17. So we have to decide, is 17 positive, is 17 negative, or is 17 0? Because that tells us what our solutions are. Well, 17 is clearly a positive number, so that tells us that there are 2 real solutions. Okay, because 17 was positive, that tells us there's 2 real solutions. So let's do the same thing with the next question. So first of all, we're going to identify what A, B, and C are. So A is the number in front of x squared, which is 5. B is the number in front of x, which is 4. C is the number by itself, which is negative 3. So my formula, remember, is b squared minus 4ac. So b is 4, so that's 4 squared minus 4 times a is 5 times c is negative 3. And we're just going to type that in the calculator. And when you type all of that in, you're going to get an answer of positive 76. So since that is positive, that tells us there are 2 real solutions. Okay. So looking at the next one, we're going to identify A, B, and C. So A is the number in front of x squared, which is 4. B is the number in front of x, which is 12. C is the number by itself, which is 9. And our formula, again, is b squared minus 4ac. So we're going to plug our numbers in. So that's 12 squared minus 4 times 9. Well, if we type that in our calculator, 12 squared minus 4 times 9, we're going to get 0. So since we got 0, looking back at the previous page, that tells us that we have, in this problem, 1 real solution. Okay? When our discriminant gives us 0, that tells us there's only 1 real solution. So looking at our last one, or the next one. So A is 9. B is 6, and C is 1. So our discriminant formula again is b squared minus 4ac. So we're going to plug our numbers in, so that's going to be 6 squared minus 4 times 9 times 1. Well, that's going to give us 0 when we put it in the calculator. So since we got 0, that tells us again this has 1 real solution. And our last problem, same thing, we're going to do A, B, and C. So A is 1, B is 2, and C is 7. So our discriminant formula, b squared minus 4ac. So that's going to be 2 squared minus 4 times 1 times 7. When you type all that in the calculator, you're going to get negative 24. So this number, because it was negative, that tells us that there are no real solutions. So this particular problem, that means when we graph it, it's going to look like this. It's never going to touch the x-axis. So there's no real solutions. Okay, so moving down to where it says page 9, the quadratic formula also helps you find the roots of a quadratic polynomial. That should say of, not or values at which the equation's graph crosses the x-axis. To find the roots, you need to set the polynomial equal to 0 and use the quadratic formula to solve. So this time we're actually going to use the quadratic formula. If the graph of a polynomial does not meet the x-axis, then the polynomial has 0 roots, and the discriminant will be negative. We're going to talk about what that looks like. So if we're looking for the polynomial's roots, we're going to be using our quadratic formula now. The quadratic formula, we wrote that on the first page, is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're doing the same thing. We're figuring out what a, b, and c are first. So a, b, and c. So a is going to be, in this case, 1. B is going to be 3, and C is going to be 1. So we're still plugging those numbers in just like we did with the discriminant. Our formula is just a little bit longer. Now, most people get confused by this whole plus minus thing here. But don't worry, that part's not confusing, okay? The only thing you have to do with the plus minus is that means you do the formula twice. And one time you add and one time you subtract. So I'm still going to plug in all my numbers. So this negative b, make sure you always put that negative sign there. That really means the opposite of b. It really means the opposite of b. So right now b is positive 3, so in the formula it would be negative 3 plus or minus the square root of b squared would be 3 squared minus 4 times a is 1 times c is 1 all over 2 times 1, because that's what a is. I would first find the discriminant. I would plug in this part and see what that is. Not the square root, just the actual number. So type in the calculator 3 squared minus 4 times 1 times 1. I'm going to tell you that's going to give you 5. And then 2 times 1 is 2. So the question is, can you actually take the square root of 5? Can you actually take the square root of 5? And the answer to that is no. I mean, you can, but it's going to give you a decimal. So since you can't actually take the square root, this is your answer. In your answer choices, a lot of times it will say negative 3 plus the square root of 5 over 2, and you'll have a second one that says negative 3 minus the square root of 5 over 2. But these two both here are your answers. So let's look at the next one. X squared plus 4x plus 3. So we're going to identify A, B, and C. A is the number in front of x squared, which is 1. B is the number in front of x, which is 4. C is the number by itself, which is 3. So remember my quadratic formula. I'm going to write again. You don't have to keep writing this because it is on your notes, but I'm writing it on here so you can see it. So I'm just plugging in numbers. So negative b is going to be negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 3 all over 2 times 1. First thing I want you to do is I want you to put this part here in the calculator and see what that gives you. So if we type in 4 squared minus 4 times 1 times 3, we're going to end up with 4. 4 squared is 16. 4 times 1 times 3 is 12. 16 minus 12 gives us this 4 here. That's where that comes from. And then 2 times 1, the denominator is just 2. Well, in this case, we can take the square root of 4. And the square root of 4 is 2. So this problem really becomes negative 4 plus 2 divided by 2 and negative 4 minus 2 divided by 2. So we need to figure out what this is. Well, negative 4 plus 2 is negative 2. And negative 2 divided by 2 is negative 1. Negative 4 minus 2 is negative 6, and negative 6 divided by 2 is negative 3. So in this case, I was actually able to figure out what my solutions were. They were negative 1 and negative 3. I'm only going to do one problem with you because we've done a whole lot, so I want you on your own to do 1, 2, and 3. I'm going to do number 4. So I'm going to identify A, B, and C. Notice they wrote the quadratic formula for you up here at the top. So this is the quadratic formula. The discriminant, because you'll need that formula a lot, remember, is just the part b squared minus 4ac. And you'll need to reference that on the very first page, that table that we drew that had whether if the discriminant was positive, negative, and 0, and how many solutions that meant. That's going to come in handy. So I'm going to identify A, B, and C. A is 3, B is 2, C is 5, so I'm going to plug in my numbers. So my formula number is negative b, so that's negative 2, plus or minus the square root of b squared, so that would be 2 squared, minus 4 times a, which is 3, times c is 5, all divided by 2 times 3. First thing you always want to do is plug this part right here. Do not plug the square root in, just that part. 2 squared minus 4 times 3 times 5, which is going to give you negative 56. So we have 2 plus or minus the square root of negative 56 divided by 6. And that would be our answer. We can't do anything else with this because two things. Number one, you can't take the square root of 56. That's not possible. Two, there's a negative here, so we can't really do anything with that. So we would look for our answers that said negative 2 plus the square root of 56 over 6 and negative 2 minus the square root of negative 56 over 6. So there's one more thing I want to cover with you, and it's not going to be the quadratic formula. But you're going to have some questions that are going to ask you about the type of roots. It will say the polynomial below has blank roots. So let's talk about the roots. Okay? When we're talking about the roots, we're talking about where the graph crosses the x-axis. Where the graph crosses the x-axis. So if we wanted to know the type of roots that this problem right here, as we're going to use problem 5, 4x squared plus 3x minus 1. 4x squared plus 3x minus 1. So you're going to have options. You're going to have options like 2 positive. I'm going to give you some answer choices here. 2 positive, 2 negative, 1 positive and 1 negative, or you're going to have an option of 2 complex. In order to figure this out, we actually have to graph this equation. So we're going to go to y equals, and we're going to graph 4x squared plus 3x minus 1. And we're going to see what that graph looks like. So I'm going to sketch the graph for you. When you graph it, your graph should look something like this. It's not the best strong graph in the world, but you get the idea. So our roots are this point here and this point here. This particular question is asking you not necessarily what the actual numbers are, but what you know about them. And so when you look at this number here, you know because it's on the right side of the y-axis, it's positive. And when you look at this one, it's negative. So that means our answer would be C, 1 positive and 1 negative. So in order for a graph to have 2 complex roots, remember it's going to have to look like this. This would have 2 complex. Okay. If your graph looked like this, it would have 2 positive. And the reason it has 2 positive is because it crosses the x-axis twice, and both those values are positive. If it had 2 negative, then it would cross both times on the left-hand side. This would be 2 negative. And then if it only had 1, because that's sometimes an option as well, then your graph would look like this, where it just comes down and touches the x-axis. So this would have 1. And this case would be 1 positive. If it was over here, it would be 1 negative.